Hello, my name is Steven, and I'm going to be making the matrix theory video. How about we get right into it? The first thing we're going to talk about are matrices. So a reasonable question one might ask is, what's a matrix? A matrix is an array of numbers. And generally, you put these numbers in between brackets. 2, 3, 4, 1, negative 2, 8. This is a matrix. Okay. Now, there are a number of things we can do to matrices, but the first thing we're going to talk about is the size of a matrix. This is a blank by blank matrix. And we're going to put a number here and another number there. The first number will be the number of rows. The next number will be the number of columns. This is the first row of numbers. This is the second row of numbers. And there is no third row of numbers. That is, there are two rows. This is called row 1, 2, 3, 4, and 1, negative 2, 8. That's the entries in row 3. Excuse me, in row number 2. Row 1, row 2. Now, how many columns are there? Well, columns go up and down. That's column 1. 3, negative 2 is column 2. And 4, 8 is column 3. There are 3 columns. So we call this a 2 by 3 matrix. Somebody asks you, what is the size of this matrix in front of us? You say, oh, it's a 2 by 3. If you're given 2, negative 2, 4, 5, 1, 7, 0, 8, 2/3, the square root of 7, pi, and pi cubed. How many? This is a blank by blank matrix. Well, how many rows are there? Straight across is row 1. Straight across from here is row 2. And lastly, row 3. There are 3 rows. The first entry here must be the number of rows. The next entry is the number of columns. There is 1 column, a second column, 3 columns, 4 columns. This is a 3 by 4 matrix. This is a 3 by 4 matrix. The one above is a 2 by 3 matrix. And like I said, there's a number of things that you can do with matrices. The first thing we're going to talk about is adding matrices. How do you add matrices? You have 2, 4, 1, 3, 1, negative 2. And you also have another matrix, negative 3, 0, 4, 2, negative 1, 4. You want to add them. Now, before you can add them, before you can add 2 matrices, and generally, matrices are denoted by capital letters from the beginning of the alphabet. Matrix A, oops, that's supposed to be a B, and matrix B. How much is A plus B? They need to be the same size. And when you add them up, you get the same size as the other 2 matrices. You basically add the numbers in the same location. Top left, 2 plus negative 3, that's negative 1. And I put it in the same place, top left. To the right of that top left number is 4 and 0. And of course I add them. 4 plus 0 is 4. Put it in the same location. You might say that this entry is in row 1, column 2. Likewise with that entry. It's in the first row, but but it's in the second column. Row 1, column 2. And then you add row 1, column 3. 1 plus 4. That's 4. Then you go on to the second row. This is the second row. I'm going to add it to this second row. So I'm going to put the answers in the second row. First column entry, 3 and 2. I will add them. 3 plus 2 is 5. Next one. 1 plus negative 1. 0. Bottom right, for second row, third column. Negative 2 plus 4. That's 2. And there's your answer. Add the numbers in the same exact location. That is why they have to be the same size. For example, if there were a 3 and a 2 here, you could not add these two matrices. Because what would you add this 3 to? Okay, they have to be the exact same size. Subtraction, the subtraction of two matrices, exactly the same. Except this time we subtract. If you were given that matrix A is 1, 3, 1, 2, 0, 4, and matrix B is equal to 3, 1, negative 1, negative 3, 2, negative 2, and you are asked to compute A minus B. Well, there are 1, 2, 3 rows, and there are 2 columns. And that's true in matrix A and B. So we're going to get the same size matrix. You can do rows, one row at a time. You can subtract columns at a time if you prefer. 1, I'll do rows. That is, I'll do the 1 first and then the 3. 1, take away 3, negative 2. 3, take away 1, is 2. Second row. 1 minus a negative 1. Well, we all know that 1 minus 1 is 0. We all know that 1 minus 1 gives you 0. Therefore, 1 minus a negative 1 can't be 0. It happens to be 2. 2, take away a negative 3. 2, take away a negative 3. You have a rule that says that you can change both of those signs. Change the operation from subtraction to addition, and change a negative 3 to positive 3. And now you can just call that 3, because positive 3 is 3. So you have 2 plus 3. That's 5. 0, take away 2. That's negative 2. 4, take away negative 2. That's 6. And here is A minus B. The next thing we can do in matrices is what's called scalar multiplication. Just a big word, but doesn't mean very much. It's a simple process. Naturally, it means a lot, but it's a simple process. 3 times this matrix. Doesn't matter what size this matrix is. Basically, you take all 6 entries, 1, 2, 3, 4, 5, and 6, and you multiply it by the number in front. And when you multiply the top left number by 3, guess what? You put that answer in the top left corner. 3 times 2 is 6. 3 times negative 3, negative 9. 3 times 1 is 3. 3 times 4 is 12. 3 times 7, 21. 3 times 2, 6. Basically, it's just 6 multiplication questions. Somebody wants to know What's 3 times 2 is, what's 3 times negative 3, what's 3 times 1 is, what's 3 times 4 is, how much is 3 times 7, and how much is 3 times 2. They want to give you 6 problems at once. So they give it to you in matrix form. 3 times 2 is 6. 3 times negative 3 is negative 9. 3 times 7, 21. 3 times 2, 6. Do the same for the second row. Now, we can put all of what we've done so far together. You can put it completely together. What does that mean? That means scalar multiplication along with addition and subtraction. Suppose you come to know that matrix A is 2, 0, 3, 1. That matrix B is negative 2, 3, 0, 1. And matrix C happens to be 1, 2, 3, negative 4. That's given. And you were being asked to find the following. Find 3A minus 2B plus 5C. That is, so it's 3A minus 2B plus 5C equals, well, it's 3 times A, and A is this matrix, minus 2 times B, B is this matrix here, negative 2, 3, 0, 1, plus 5 times matrix C, which is 1, 2, 3, negative 4. Before you can add and subtract, you have to do the scalar multiplication first. That is, it's this matrix minus this matrix plus that matrix. And what is this first matrix? How much is this first matrix? Well, the answer is, the procedure is to multiply each of the entries in that matrix by 3. 3 times 2, 3 times 0, 3 times 3, 3 times 1, minus. Now, multiply matrix B by 2. 2 times negative 2 is negative 4. 2 times 3 is 6. 2 times 0 is 0. 2 times 1 is 2. Now, a lot of people, especially teachers, they don't believe in subtraction. I have absolutely nothing against subtraction. It's not a bad thing to subtract. But some people, some instructors may say, you know what, consider that as negative 2 and distribute the negative 2. You can do that. And you can put your results inside the matrix brackets. But then add, don't subtract. Okay, plus, and we multiply each entry by 5. And we put them in the same location. 5 times 1 is 5. 5 times 2. 5 times 3. 5 times negative 4 is negative 20. Okay, so now what we want to do is add and subtract. And since all the matrices are the same size, we can do it. For the top left, we have to do 6 minus a negative 4 plus a 5. Well, like I said earlier, you can always change the operation, whether it's addition or subtraction. You can switch it to the other one. Subtraction becomes addition. Change the sign of the second number. 6 plus 4 is straightforward. 10 plus 5 more. We get our answer 15. Top right corner. 0 minus 6 is negative 6 plus 10. Negative 6 plus 10 is the same as 10 minus 6, or 4. So 4 goes here. 9 take away 0 is 9. Add 15, you get 24. 3, take away 2, that's 1. Add negative 20. 1 plus negative 20, why, that's the same as 1 minus 20. The best way to do 1 minus 20 is to read it backwards. 20 positive you have the wrong sign. It's not positive 19, but rather negative 19. There it is. How about we try one more like this? Very straightforward problems. You add and you multiply and you add and subtract numbers. Just doing many at the same time. It's just doing many of these at the same time. That is, we're doing many of these. What is 2 times 4 minus 3 times 5 plus 7 times 2? Just doing many of these at the same time. What am I talking about? Well, if you were told that A is 4, 1, 0, 1, and matrix B is 5, 0, 0, 1, and matrix D is 1, 0, let's make that 2, 2, 0, 3, 0, and you are asked to find 2A minus 3B plus 7D. Okay, so it is 2 times A, 4, 1, 0, 1, that's A, minus 3 times B, but B is 5, 0, 0, 1, plus 7D's, 2, 0, 3, 0. Well, when you multiply matrix A by 2, you get 8, 2, 0, 2. Notice, okay, minus, and you multiply this matrix, that is each entry in the matrix, by the scalar 3. 3 times 5, 3 times 0, 3 times 0, 3 times 1. Plus, now you multiply this matrix, or the entries of that matrix, by 7. 7 times 2, 7 times 0, 7 times 3, and 7 times 0. And you add. Well, at the top I said we do problems like this. Well, if you concentrate on the top left entry, the first thing I did was multiply 2 by 4, 3 by 5, and 7 times 2. And I subtracted and added them, just like it tells me to. Okay. I hate getting negative numbers, like 8 minus 15 is negative. You know what? I'm going to do 8 plus 14 first, get 22. Now I'll take away 15. 22 take away 15 is 12. Okay, now I know I'm not happy with that. 22 take away 15 is the number 7. 2 take away 0 is 2. Add 0. 2 plus 0 is 2. 0 take away 0 is 0. You add 21. 0 plus 21 is 21. Two take away 3 is negative 1. You add 0. Negative 1 plus 0 is negative 1. There it is. First, calculate 2 times A. Here it is right here. Next, calculate 3 times B. Here it is. Lastly, calculate 7 times D. There it is. Now and only now do you add and subtract the matrices. Okay, this finishes the first section on Introduction to Matrices. Hope it was helpful.